What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about volume and surface area. Volume is how much it takes to fill in that box or that can, right? Or that upside down cone. So, how much ice cream, melted ice cream, am I losing? And a sphere, how much ice cream can I put in there, right? Or heck, how much water can I put in? Do I need to fill a pool? That will probably be something like that, or a hot tub, right? Or one of those blow up hot tubs, right? So, box like shapes, there is a length, there is a width, there's a height. Volume would be the length times the width times the height. Now, because of a cube where all sides are the same, you could call it as S cubed, which is length times width times height still, but that just the length and the width and the height are all the same thing, which is S. All right. So you can use either one, it's certainly fine. This right here is a cylinder, kind of looks like a can, right? So the volume for that is, now, the easiest way to do this is this, okay? So I want to say it this way. The volume of this is going to be the area of one of the sides, or I should say area of the base times the height. Well, what's the base? The base is a circle. Circle, what's the area of a circle? The area of a circle is pi r squared. And what is this right here? The height. Awesome. So it's going to be pi r squared times the height. Okay? All right. So that is the case right there. All right? So same thing here. Except that would be absolutely correct if it was talking about the area of the base here times the height. If we were talking about a box-like shape, because if you look at this, didn't we just take the area of the base times the height? We did, because the base would be length times width and then times the height. That's exactly what we did. All right, so with any of these 3D objects, that's exactly what we did. The only issue with this, however, is the fact that it doesn't go straight up. If it went straight up, it would be this shape right here. It doesn't go straight up, so what it is that it's only a third of it. So, yes, we still want to know the area of the base of this pyramid, okay? And then multiply that by the height and then take a third of it. The cone is the same idea, except with a basically it's like this cylinder, but you're shaving off the sides so that you can have a cone, and that would be 1/3 of a cylinder. Okay, so the volume of a cylinder is pi r squared times h. This would be a third of that. And a sphere is 4/3 pi r cubed. So be careful with that. 4/3 pi r cubed. All right, so these are volumes that you'll probably, formula-wise, that you'll probably be given. And then we talk about the surface area. So when we look at a box, right? When we look at a box, we can take a box apart, right? If you look down here, what I'm doing is I'm taking this box right here. I'm taking this box right here, and what I'm doing is I'm pulling off the back and I'm pulling off the front. So I'm just taking this piece right here, pull it towards me, and taking this back piece right here and pushing it away from me. Okay, so that I can see that I have two pieces that have the same area, which would be the length times the height, right? And then over here with top and bottom, I'm taking this top piece here and pushing it up, and this bottom piece here and pushing it down. Seeing again, I have two pieces with the same area, which is length times width. And again, I got two of them there. Then I'm taking the side and putting it off this way, and taking this side and pushing it off that way. So I see again I have two surface areas that are just regular rectangles, which is the height times the width, or the width times the height. Okay, so that's what I'm showing right here. So because these two are the same, that means I got two of them. These two are the same, so I got two of these. And these two are the same, so I got two of these. So the grand total of the surface area for this box-like shape would be something like this right here. Two of these plus two of these plus two of these. That will make the total surface area. And for a cube, the surface area, all the length, the height, and the width will all get replaced with s, right? So if that's the case, s times s is s squared. So this is 2s squared. This is 2s squared, and this is 2s squared. So I'll have 6 of those s squares, right? For a cylinder, if I was to take this right here and pull the lid off and the bottom off, I will have two circles. Okay, those circles, the area of those two circles, pi r squared for both the top and the bottom, because it's a cylinder, so they're exactly the same. Now, the wall of the cylinder, however, if I was to unwrap it, it would literally come out to be like a square, as long as I cut it off exactly straight. Well, with that being said, this is a rectangle, but what do you notice? That this right here, which is the base of this rectangle, wraps all the way around that circle. So what wraps around all the way around the edge of the circle? That would be called the circumference. So that's why you see it here. So the distance here, or the length of this rectangle, is the circumference of the circle. So since I know that area is equal to base times height, I know that base is going to be the circumference of a circle times the height of that cylinder. So from there, I can either have it as pi d times h or 2 pi r times h. Of course, plus this, okay? So let me see here. I guess I didn't write this all out, huh? So the total area is going to equal to 2 times the pi r squared plus pi d times h. Better yet, two pi r times h. There we go. All right. So that would be my so-called total surface area of a cylinder. All right. So let's do this example right here. Find the volume of the figure to the right. So the total volume is equal to what? Well, what do I have right here? Oopsies. Right? What do I have right here? What I have there is a half of a sphere. So it'll be the volume of half of a sphere. Plus the volume of a cone. Okay. So this volume here is going to equal to half of what? What is the volume of a sphere? Well, that is going to be 4/3 pi r cubed plus the volume of a cone. That's going to be 1/3 pi r squared times h. Okay. So my question is, what is the radius? Well, since this is showing the full width of this, that means that must be the diameter. So I want to know what the radius is. Well, that means the radius must be half of this, which would be 9. So the volume is equal to 1/2 times 4/3 times pi times 9 to the third plus 1/3 pi and again radius was 9 and what's the height? 22. Okay, so that means my volume is equal to 1/2 times 4/3 times 729 plus 1/3 times 81 times 22. Oops, I forgot it's a pi. I was trying to group all the numbers together and I forgot the pi. There we go. So now both pi's are there. So 1/2 times 4/3 pi times 729 is equal to 486 plus 594 pi, and it's going to equal to 1080 pi. So this is actually part of question A, which means that this is the exact answer. And B would be that whatever pi might be, I'm going to go ahead and use the calculator and submit it that way. Interesting. Where's my phone? Okay, there it is. Okay, so my volume is going to be 3392.92. And that's, I believe that's right. But what is the measurement? Well, it's in feet. So if you look at this, right, let's take a look. This is feet times feet times feet, so that's feet cubed. This right here is feet times feet times feet, which is again is feet cubed. So we got cubic feet here. Okay, so this would be the approximate. Answer, and that part A would be the exact answer. Well, I hope that helps. If there's any questions, please let me know. Talk to you later. See you. Bye.